I have here the law of sines, and in order to understand when you can use the law of cosines, we'll show where the law of sines fails. And here I have what's going to turn out to be a 3, 4, 5 right triangle, and we know this is 90 degrees. What I see here is that I have a C, which is 3. I have a B, which is 4, so I'll substitute that here. And finally, I know what angle A is. It's 90 degrees, so this would be the sine of 90 degrees. And the problem that we're facing is that I don't know any of the three side to angle ratios in order for us to form a proportion with any two of these ratios. So in order to use the law of sines, I need to know if I have one of the angles, I need to know the side opposite one of the angles. Over here, I have the measure of the side, but I don't know the measure of the angle, and the same here. So I would need two of these and one of these in order to be able to use law of sines. So in a situation where we have side angle side or side side side, and we can't form a ratio between angles and sides, we can use the law of cosines. And the law of cosines takes three different forms. And in each case, I'm solving for the square of the side that I don't know. In this case, it's going to be A, and I have the length of C. I don't have the angle C. I have the length of B. I don't have angle B, but I do have angle A. So now substituting on the next line for the things that I have. So B is 4, C is 3. I've substituted those in. Now I'll simplify. 4 squared is 16, plus 3 squared is 9, minus 2 times 4 times 3 is 24, times the cosine of 90 degrees. Now for the cosine of 90 degrees, before I even do anything on the calculator, I need to first make sure that I'm in degree mode and not radian. So first click on mode. And then I see here on the third line, this is set to radian, so that needs to be degrees or I'll get the wrong answer. So I come down 2 with the arrows, 1 to the right, push enter, and now my calculator is set up for degrees. To exit the mode, I push second and quit. And now I'm going to do cosine of 90 degrees, which is 0. And now, when I simplify, I get 25 minus 0, or 25. So I have a squared equals 25. And from here, I simply take the square root of both sides, and the square root of a squared is a, and the square root of 25 is 5. So then we have a equals 5. Once we're at this point, since we have an angle that's opposite a measurement side, we would then be able to use the law of sines, which would have the ratio of the side A over the sine of angle A. This next example, I don't have any of the angles, but I do have all three sides. So I would be able to use any one of these, but we're going to try to find the measure of angle A here. So I'm going to substitute my small a, small b, and small c into any of the formulas. Since they're all written here, I'll just use the first one. So substituting in, so that's 7.92 squared equals 11 squared plus 8 squared minus 2 times 11 times 8 times cosine A. So on the next line, I've squared all the terms. Now I'll simplify. 121 plus 64 is 185. I'll subtract 185 from both sides. Then divide both sides by minus 176. And then in order to find out what angle A is, the cosine of angle A is 0.6947. So I'll find what's called the arc cosine. So I push second and cosine, and I'm putting in 0.6947. Close parentheses, enter, and it's about 46 degrees. So now once I have one of the angles and I have a side opposite that angle, I'm able to again use the law of sines because I can form a ratio with these two. Once I get the next angle using law of sines, then I just subtract from 180 degrees to get the third angle. Let's try one more example. In this triangle, we see that we have an angle that is in between our A and B, but we don't have C. So once again, we can't make a ratio between sides and angles. So we have to use the law of cosines. Since we have A and B and we have angle C, the one that this matches best would be the third one here because we can substitute in for A and B 2 times. And then we have the angle C, so we can find the cosine of C. So we'll take away the first two. So with the third one, we're finding C squared, which is opposite the angle that we do have. So we'll substitute in our A's and B's here. So here I've got A squared, which is 8 squared. I have B squared, which is 10 squared. I've substituted in the 8 and 10 for the B, and I've put in cosine of 42 degrees. On the next line, we'll simplify. So I have 64 plus 100 minus 2 times 8 is 16 times 10 is 160. And the cosine of 42, we can go to the calculator here. So I push cosine 4, 2, and I get 0.743. And now I'm able to further simplify on the next line. So I have 164 minus times 160 gives me 118.903. And I'll just subtract these two. And now I'll take the square root of both sides. So to get the square root of 45.1, the square root button is a second function on the x squared, so I push second, the x squared button, I put 45.1 inside, and my side is approximately 6.72. And as before, since I now have an angle and the side opposite it, I now have a ratio between the two. I can use the law of sines for the remaining two angles here. I just wanted to add this small section at the back of helping you to memorize the formulas. So the first one, the first form was a squared equals, and then the two pieces that are missing would be b squared and c squared. And the order doesn't matter because when you're adding, the commutative property lets you reverse that. Then you have minus 2, and then it's again b and c times the cosine, and whatever's over here, a, is going to be the cosine of that angle. And if we move on to b squared, well, then once again, the two pieces that you're missing are a and c, so those are going to be the ones that are squared, minus, and then a and c again, 2ac, and this time cosine, whatever was over here, b, so it's going to be cosine angle b. And then the final one, c squared, equals, and then the two pieces that you're missing are this time going to be a and b, so it's a squared and b squared. Again, the order doesn't matter because of the commutative property. And same thing here, it's a and b, and it doesn't matter which one comes first because the commutative property also applies to multiplication. And then it's cosine of whatever was on the outside, which is side c would go with angle c. So I hope that helps to memorize them. If you're interested in seeing a video of how this is derived, leave a comment below and I'll make the video for you.